Alright, the next word problem says a gear is initially rotating at 12 radians per second and accelerates at 5.2 radians per second squared for 20 seconds. Find the angular velocity or angular rotation of the wheel. So find the angular velocity. So go ahead and pause, try to solve this, and when you're ready, unpause. Alright, let's write down what we have. So there's a 12 radians per second, that's an angular velocity. There's a 5.2 radians per second squared, which is an angular velocity. And you have 20 seconds, which is time. And you're trying to find the final angular velocity. So in this case here, this is going to be the initial angular velocity. So this is a direct plug-in. The angular acceleration is going to be the final angular speed minus the initial angular speed divided by time. And so we'll just plug in 5.2 is going to equal omega final. Omega initial is 12 over time, which is 20. Solving for omega final, that's going to be equal to 12 plus 5.2 times 20. And that will give you a final angular velocity of 116 radians per second. Alright, let's try this next word problem. It says a car with a mass of 1,020 kilograms rounds a curve with that has a radius of 500 meters. If the friction force between the road and a car provides a centripetal force of 2,500 newtons, how fast can a car travel over the curve without skidding? So go ahead and pause, try to solve this, and when you're ready, unpause. Let's write down what we have. So here, you have 20 kilograms, which is mass, and 500 meters, which is a distance, but next to it is radius, so this is r, and we have 2,500 newtons, which is a force, and I'm trying to find the velocity. So what's happening is that there's a curve, and the car is rounding the curve. So the car is moving with the speed v over the curve, and there's a frictional force that's applying a centripetal force. So the frictional force is pointing inwards. So the force that's given here, this actually the frictional force, which is also going to be the centripetal. And the curve has a radius r. And we're trying to find the radius. We're trying to find the velocity that the car rounds a curve. So this is a centripetal force equation. So the centripetal force is going to be the mass, the velocity squared over the radius. So you can plug in the centripetal force is the same as the frictional force. So 2,500, and that equals the mass, which is 1020, multiplied by the velocity squared that we don't know, and divided by the radius, which is going to be 500. And doing the algebra, you'll get that the velocity squared is going to be 25,000 times 500 divided by 1020. And the last thing is to get rid of the square root. Take the square root of both sides, so that the square root cancels out the power of 2. And so the velocity is going to be the square root of 2,500 multiplied by 500 divided by 1020. And that will be 35 meters per second.